Hello guys, and welcome to Building a Cisco Lab Part 2. This is Kaveh here, and in this video I will be talking about the hardware which is required to build a Cisco Lab using GNS3 and QuadNex. Alright, so let's have a quick look at the big picture. This is the final configuration that I have after building the lab. I have a PC, or it can be a desktop or a laptop that normally is connected to your home or office network. It's going to be on one subnet. It's going to be connected to the internet. You could actually use that PC to connect to your lab remotely through a wireless access point. And from that access point, actually you have some connections to your GNS3 server or to your access switch or access server, which I'll talk about that a little bit later on in this video. And of course, all of your layer 3 switches will be connected through Ethernet cables to the QuadNex on your GNS3 server. On the other hand, we have some console cables which are connected from your layer 3 switches to your access server. So what we need is actually we need to build a GNS3 server. We need some layer 3 switches to buy and install those in our lab, and finally we need some Cat5 Ethernet cables to interconnect all of those devices. As an optional part, you may actually want to get an access server here so that you have a more comfortable way of accessing your real switches. You may want to have an wireless router or access point actually to be able to remotely connect to your lab. And finally, you may want to have a lab so that you can actually mount all of those stuff on a lab, on a rack. Alright, so let's move on. The first step will be to build the GNS3 server. And the challenge is the network interface cards. So overall you have two options for your network interface cards. The first option will be to use a PCI Express card, and the second option will be to use a PCI-X card. These are two different technologies. Most of the time people are confused by that X or Express, but PCI Express is a most recent technology. This is basically the type of PCI that you find out these days on most of the desktop motherboards. You install your graphic card in this type of port, and they come in actually three flavors. You could have PCI Express 16, or they call it X16, or you could actually have PCI Express 1. As you can see here, it's a very small slot. Or you could actually have PCI Express X4, which is not shown in this picture, but it should be a little bit shorter than this one. So it's like half of this port, and this is called PCI Express X4. But these are the most recent technologies that are out there. The only problem with that method is that these cards are very expensive. So if you want to get a PCI Express QuadNex, they normally run about $200 to $300 per each. So it's a very expensive solution, but point is that it's a newer technology. Normally you get gigabit ports on these cards, and it can be installed on either PCI X16 or PCI X4 on your motherboard. So if you go with this solution, what you need is that you need to at least have 3 PCI Express cards on your desktop, or if you have a server motherboard, on your server motherboard. Alright, so the second solution, which is a much cheaper solution, is a PCI-X solution. PCI-X is somehow an older technology which came out after the PCI, the legacy PCI 32-bit technology, which basically is designed more toward the server boards. You normally find a PCI-X slot on server boards rather than a desktop board. These slots actually designed to support QuadNex or RAID controllers that you normally have on the server boards. But anyway, the PCI-X is a much cheaper solution because it's an older technology. These cards can be basically purchased probably around $20–30 off eBay, compared to the newer technology, which is PCI Express, that you are gonna probably end up paying $200–300 per card. So for the PCI-X cards, you may have actually two different types. The first type is the cards that are actually backward compatible. These cards can be installed either in a PCI-X or PCI slot. So whenever you have a backward compatible card, you could install that in this card in either a PCI-X, which is a very long slot as you can see here, either a PCI-X slot, or you could install those in a all legacy 32-bit PCI slots. Alright, so if you go with the solution, what you need is that you need a motherboard that has at least 3 PCI slots, or some PCI X slots, or some PCI slots. So I have listed a couple of cards that actually people have been using for the last couple of years to build this configuration. The Link models have been very popular because of the flexibility and supporting and the support in the iOSs, but I wasn't actually able to find any of those cards. I mean, I was able to find the Adaptec and HP, but or the SunQuad, but the problem is that many people were complaining about installing the drivers of those on the computer. So I decided to go with the Intel solution, which I'll talk about that right now. The PCI-X card that I found, two flavors, is the Intel Pro 1000 GT and Intel Pro 1000 MT. And the difference is that in the GT model you got basically a quad NIC card with gigabit interfaces, while on the MT you get fast Ethernet interfaces. But anyway, the problem with this Intel models is that they are not backward compatible, so you cannot install those cards on a legacy PCI port. You definitely need at least 3 PCI-X slots on your motherboard so that you'll be able to actually install those cards. Alright, so many people ask this question, that how we're gonna basically find out if a card is a backward compatible or it's not. Well, you gotta have a look at the documents, but sometimes documents are not accurate enough. For example, for those Intel Pro cards, if you look at the document, it says PCI-X/PCI, while you actually will not be able to install those cards in a PCI slot. And the reason is that if you look at here, there's a little marking here, though it looks like a dent, but it's not. Actually, it's not a dent or a slot. So it's a solid board here, so you could not actually install these cards in a PCI slot. While with the older models, which I've talked about, the backward compatible models, they are actually have a dent here. See that? They have a little slot here that you could actually install those on the boards. Anyway, so with this introduction, you get an idea what are your options on the NIC card. Alright, so most of the people go with the cheaper solution because, of course, the whole idea here is that to build a decent lab with less cost. So let's move on. As an example, I can basically give you some examples of different configuration that you could have. For example, you could pick 3 of those newer PCI Express cards and build a good i5 and i7 system. It costs a lot, probably around $1,500, but at the end of the day you have a server which is more recent, which has more recent hardware, and it could be used later on for other applications, like if you want to use it for cloud computing or whatever you want to practice later on. So that's a great solution, but it's very expensive because you're going to probably end up paying about at least $600 just for the NIC cards. The other solution actually will be to use those PCI compatible cards. If you could get those PCI-X cards out there and build a system and pick a motherboard that has at least 3 PCI slots on it, then it's a great solution. It costs much less, and again, your system is somehow kind of up to date and you could use it. But the last method which I can mention here is that I actually use some older servers, like ready to go old servers that are available out there. The one model which I was able to find off eBay is the Dell PowerEdge 840. This is a great server. Normally they come with quad-core processor or Xeon processor. These are great servers. They are very cheap. Actually, if you look at eBay, most probably you're going to be able to find those around $200 for the whole system, including motherboard, processor, hard drive, and everything. So this is a great solution. The good thing about this specific server is that it has 2 PCI-X slots on the motherboard, and it has 1 PCI just PCI 32-bit slot. It even has some PCI Express on the card, so you get a bunch of different slots on just one motherboard. And I have checked actually this server. I had an access to one of those, and I installed two of those PCI X non-compatibles on the PCI X slots, and it runs pretty smooth. I had no problem installing those cards. That's a great solution. You got a onboard VGA, basically graphic card, and of course you get an onboard gigabit Ethernet card on the board. So that's a great solution. Definitely this solution gonna be on budget. You just pay for the server, the whole server as a package, and then you buy some cards and install it in those. But let's have a look at my solution. So after looking at different solution, I ended up building my server with this parts. I picked Intel Pro 1000 GT quad, which are the great cards with 4 gigabit Ethernet on each card, and these are PCI X. They are not backward compatible, so I definitely have to pick up a motherboard that has at least 3 PCI X slots. I ended up paying about $75 for the cards in total, so it means that $25 per each. For the motherboard, I picked Supermicro PDSM4 Plus, which is an amazing motherboard for our application. It has 4 PCI X slots right on the board. It has 2 gigabit Ethernet ports again on the board, and it has onboard VGA. That's a great motherboard, and performance is great. The other thing about this motherboard is that it supports a wide range of processors, from quad cores to Xeons to dual cores. So you'll be very flexible on the selection of the processor for your server. I picked an Intel Xeon 3220, runs at 2.4 gigahertz, 8 megabyte of cache, and it's a quad core processor, and it's an amazing fast processor for this application. I ended up paying about $100 with the fan for this processor, which is really cheap compared to the performance that you're getting with this processor. I picked up some RAMs, DDR2 RAMs, about 4 gigabyte. You could actually install up to 8 gigabyte on this motherboard, but I think that will be more than enough for our application. Of course, you need a hard drive for this server, and finally a rack mount case. Well, I picked a rack mount case because I wanted to actually install my server on a little 12U rack, but you could actually use just normal cases for this build. And finally, the power supply. One of the most important points in building the server. If you want to use a server board like this model, then you need to have a good power supply, quality power supply. Server motherboards are very sensitive to power supply, so you're gonna have a power supply that has at least 600 watts output, real output, so that actually you can run your server smoothly. So as I said, this is the final result after installing everything. As you can see, it's a very clean and neat configuration. Alright, so after building the GNS3 server, you're gonna actually need layer 3 switches, and we normally need 4 layer 3 switches. So for this purpose, there are a bunch of options out there: the Cisco Catalyst 3550 or Cisco Catalyst 3560, or actually Cisco Catalyst 3750, which is not written here for some reason, but this is the 3750s. But anyway, what people normally do is that they get 2 of the cheapest one, which is the 3550 ones. They're much cheaper these days, under $100 per each. And then they get 2 of the newer models, which are 3560 or 3750s. So I picked up actually 2 3550, which are great layer 3 switches. They support most of the basically commands that you need to run on the switches, and 2 of the 3750s for more advanced IP functionality in my switches. So you need 4 switches. You can get them probably off eBay, used one, and I get those actually at a really good price. So what else we need? Of course, we need 18 Cat5 crossover to interconnect switches. Of course, depends on the topology that you're making, depends on the vendor's topology that you pick. Let's say you're picking INE or Internet Working Expert, or you are going with the IP, what are the other names, IP Expert topology, then depending on the topology that you're making, you may need actually different number of cables, but overall, if you want to interconnect your switches together, you need at least 18 Cat5 crossover cables to interconnect switches, or you need 12 straight to connect, straight through basically cables to connect switches to the GNS3 server. As I said, as an optional parts, you could have an access server, you could have wireless access point or router to remotely connect to your lab, and finally you may want to actually buy a 12U rack to be clean and neat. Alright, so about access server, what's the purpose of access server? Of course, you are in a semi-physical lab, so you have some physical devices, which means switches, which you should have somehow connect to those switches. Many people have used COM ports or RS-232 cards on the GNS server, and they connect those ports to the switches and then somehow map those COM ports in the GNS3 server to an IP and a port number, and then connect to those port numbers basically remotely. But the other solution would be actually to use Cisco 2509 access server or 2511 access server. These are Cisco routers that you can actually configure as an access server. Then you could connect your switches to those servers and connect remotely through IP to the router, and then from that router you can actually switch between console ports of each of those devices. Well, the other method which I have found is, which is an amazing way of doing it, is that using one of those DGCM console switches. And what are these? Are actually these are console over IP switches, so it means that you get a basically 16 or 32, or I believe they even have 64 port models of that you get, let's say 32 console ports in the back of the device, and you have an Ethernet interface here on the device. So what you will do is basically you connect over IP to that switch, and that switch basically gives you the access to console ports of each of your physical devices that are connected to these console ports. That's a great device. The new models are very expensive. Probably for a lab, it doesn't make sense to purchase any of those. They are running probably around $3,000 to $4,000 per each. But the older models are very cheap. You could get these switches probably cheaper than, less expensive than 2509 or 2511. If you go to eBay or somewhere similar. So this is a great way. I will have a short video that I show you how I've connected actually these access servers to real switches. Alright, so here's the final result, guys. This is a couple of pictures of the final result. Of course, this is the lab after installing everything on the rack, and this is my GNS3 server right at the bottom. It's a rack mount server, and it's a great way of actually doing this lab. Alright, I have created a short video of the lab while the lab is actually up and running. That follows right here after this this slideshow. So feel free to have a look at that video, and if you are interested in finding about the software which I've been using in this lab, I will see you in video number 3. Alright guys, here's a short video of the final result. As you can see, everything is installed in a small 12U rack. We have GNS3 server right on the bottom, and we have our layer 3 switches, two 3550s on the bottom and two 3750s on the top. And also we have our DGCM32 access switch on the top, and finally we have our wireless access point. So as you can see, I have labeled actually and bundled all the cables. This way it will be much easier for me to change the topology. If I wanted to switch to a different vendor topology, you just unplug the cables and plug it to the right switch ports. Yeah, as you can see, some of those ports are actually in the blocking state, and the spanning tree protocol is active. I haven't configured anything yet in this lab. So let's have a look at this side. As you can see, again, cables are bundled, and finally let's have a look at the access switch, which I was talking about. As you can see here, we have one fast Ethernet connection from the access switch to the access router, which gives us the IP connectivity to the access switch, and from access switch we have those console cables, which are normally you could use actually normal Cat5 straight cables to connect this specific access switch model to your physical devices. So yeah, those are the cables which are running from console ports to console ports of the physical switches. And here we have all the cables bundled and connected to back of our GNS3 server. As you can see, again, all of those are labeled so that we can easily identify those and connect those to the right ports on our GNS3 server. So this is just a short video to show you the working lab, and as you can see, actually the level of noise is not that high. It's kind of a quiet lab. I think that's it for this video. Good luck with building your own lab, and please let me know about your comment or questions on the YouTube channel or on the config101.com website. Thank you, and I will see you on the software setup story in video number 3.